John has given a very nice introduction of WorldDEM. This most accurate global elevation data is now available in ArcGIS Living Atlas of the world. Today we are going to provide an overview of elevation services, its coverage and various data sources we have, and various elevation offerings we have in Living Atlas for visualization and analysis, and how you can find and use these layers to use in your workflows. So Living Atlas of the world is a gateway to foremost collection of global geographic information from Esri. It contains thousands of layers, maps, and apps on various themes curated by Esri and its partners. These layers are compiled from best public, commercial, and community contributions with resolutions ranging from 1,000 meters to 0.5 meters. Airbus WorldDEM4Ortho is now integrated into all the elevation layers and tools. This improves all the areas outside of North America where earlier we had best data as from SRTM 30 meter. So these ready-to-use layers and tools allow users to focus on their workflows and analysis. These layers and tools can be divided into two broad categories for analysis and visualization, and pure visualizations for 2D and 3D. What elevation services are comprised, as I mentioned, from multiple data sources and resolutions. At global scales, we have 1 kilometer from JEPCO, then GMTAD, which ranges from 1 kilometer to 250 meter, and we have also have a 90 and 30 meter SRTM, which goes from North 60 to South 60. And now we included a WorldDEM4Ortho from Airbus, which covers all the land mass at 24 meter. By default, WorldDEM takes priority over SRTM and rendering results. In North America, we have 30 meter net from USGS. Then in USA, it goes down to 10 meter and 3 meter in some partial areas. In Europe, we have 10 meter available from Denmark, Finland, Norway, Austria, and Spain. And then we have few bathymetric data sources from NOAA and Geoscience Australia, which covers 150 meter in MH370, that Malaysian Airlines search area. So Esri makes it easy to work with the elevation data by offering two dynamic world elevation image services, terrain and topography. In terrain, ocean is represented as flat with elevation values of 0, while topography, as name suggests, integrates topography and bathymetry into one seamless layer. These services have server-side functions defined to generate on-the-fly derivatives such as slope and aspect. Since these services and derivatives provide access to actual data values, these are suitable to use as input to analysis in desktop applications. These services also have a roster function specifically to generate visualizations such as multi-direction hillshade, slope map, aspect map, and tinted hillshade. All these derivatives are processed on the fly during access. These services provide a single endpoint for desktop and web applications to access elevation values and derived products. Access to these global elevation layers is free with ArcGIS online subscription. Here, let's see a quick example showing improvements with the Airbus data. This is Mount Kilimanjaro in Tanzania, depicted SRTM 30 meter. And now I'm going to overlay WorldDEM4Ortho 24 meter. We have already seen a couple of examples from John's presentation, so I have just one because it was already covered by John. So this is overlaid again. I'm repeating that. Okay, this is SRTM and this is WorldDEM. So you can now clearly see the fine details in the ridges, here in the valleys, hydro features specifically, those which were not much apparent earlier with the SRTM now are very clear. So analysis such as slope calculation, which are sensitive to noise and can benefit from better elevation data of Airbus. Let's see where you can find and use these layers. And I'm going to show you a quick demo. Okay, so these world elevation layers are a part of the ArcGIS Living Atlas of the world. Here I'm on the homepage of ArcGIS Living Atlas of the world. It's a standalone website where you can see what's new, and there are a few articles from recent from our blog. And then there is a browse button, a browse tab, where the things are all the layers are organized based on various categories such as base map, imagery, environment. Elevation is subcategory to the environment, so you can click this arrow, and elevation and bathymetry are a part of environment. And this site is basically to explore what's available, and what that content is before you start using. So if I search terrain here, and it will give me some suggestions. So I can select terrain, and out of these 5 results, three results are from World Elevation Services. So you can hover your mouse and it will tell you what that is, and you can also open the terrain item for look into the further details. So this is one way. Another way is we have a focused group on ArcGIS Online, and it's called Elevation Layers. So this group is even further focused. So ArcGIS Online you can consider where everything is available. Living Atlas is subset where ESRI curated content is available. So this elevation layer group is even more focused, where only the elevation layers curated by ESRI, published by ESRI, is available. So under the content, you can again look at what are the various layers, and our terrain is our main service, and other terrain elevation, tinted hillshade, slope map are derivatives of that. Okay, so now let's open this terrain item in a separate page, which I already opened, to look at the description and what you can do with this layer. So this is a pretty detailed description here. So it will go over what this layer is, what are the various server functions available on this, such as slope degree, aspect, etc. And then what are the different data sources we have. Okay, so this lists all the data sources in various geographical locations, and you can see WorldDEM here is listed, and source is obviously Airbus, and then we have a data coverage map. So this map would be very handy if you want to learn more about where different resolutions are available. So this layer is restricted to 5,000 by 5,000 pixel limit in a sync request. Okay, so you can browse this layer in map viewer, which is ArcGIS Online, or you can do further analysis in desktop. So I'm going to show you a quick look at in map viewer. So once you add this layer, by default this will render DTM, which is a digital terrain model, and you can click anywhere and it will give you the elevation, aspect, slope. If you hover over the terrain item, there is a 3 dot which gives you more option. If I click that, under image display, there are renderers, and you can choose one of the renderers available. So these are the renderers I was showing you, or telling you that we have different raster functions. So these are basically those. So if I click one of these and apply, so this is now applied hillshade on that raw elevation values. So this is not a pre-generated, so this is a dynamic hillshade, which means every time you pan zoom, the request is sent to the server, process hillshade, and return back results for your AI. Okay, so I can quickly change to anything else. For example, here I'm change to multi-directional hillshade, and let's go to search one of the area that I was showing you earlier, so Mount Kilimanjaro here in Tanzania. And once you open that, it will render the results, and because again it's a on the fly, so it's asking data from the server, and then it will render. And from the image display you can change, so for example slope, different hill shades. Yeah, so you can toggle between different product available, or different renderers or raster functions available via this. Okay, so in ArcGIS Online Map Viewer, you can use these as a visualizations layers, but you can do more powerful analysis using the desktop applications. Okay, So now I'm going back. I'm going to show you a analysis on ArcMap. Uh, so here, I showed you earlier that you can browse through Living Atlas through Elevation Layer Group. But in this case, when I'm running analysis, there's one particular tool where I need to make ArcGIS server connection. Okay, so that's a better way when you want to control different aspects of uh, this service. So from the catalog, you can make add ArcGIS server connection, and I already made that. I can show you where you go that. So you will make a connection to elevation.arcgis.com and provide your credentials. So this need a ArcGIS subscription. So once you apply that, you can make a connection to that. So it will show you tools, World Elevation, and then one standalone service for US. Under World Elevation, you will see 3 services: data extents, terrain, and topography. So data extents where it will show you, if I click, go to the global scale. So this is data extent map that I was showing you in my presentation. So this is very handy. It will show you where at one particular location what different resolutions we have. Okay, so now I want to do analysis on my small area, and I want to use take advantage of different resolutions available. And in this case, I'm particularly interested in this WorldDEM4Ortho. Okay, and I added this terrain service already. So if you open that here, like I was showing you in ArcGIS Online, you can, and from the processing template, you can toggle between different raster functions, server raster functions we have. So in this case, I have selected the multi-direction Hillshade, and if you click on any area, it will tell you what different different sources we have at that particular location. So like I was showing you that data extent is very handy. If I click on the data extent, it will also tell you, okay, what is the product name, what is the pixel size of a data source available at this scale in this geographic area, and what is the source. Okay, so I'm going to use this product name while I'm doing my analysis. Okay, so one other thing which is important regarding when you are especially doing analysis, you want to, so this is a multi-resolution and multi-source service. Okay, so when you are doing and running analysis, you want to run analysis against a single source. So, and you want to control the cell size, you want to control the projection. Service itself is in multi sources, like I said. Okay, so but if you look at the properties of this service, it will tell you that it's a shell properties and cell size of 0.5 meter and projection as a web marketer. Okay, so those are just the shell of the underlying data sources would be of varying resolutions and projections. And you can basically, there is a make image service layer tool which you can use to basically filter the data that you want to do your analysis with. So, okay, so in this case, if you go to the source, it will tell you the cell size, 0.5 meter, and spatial reference of, so this, like I said, this is just a property of service. If I click on the resolution, click on my screen, so you will see the WorldDEM, and there are different, each record has a different fields that tell you more about that. So for example, in this case, name of that tile, low PS is the pixel size, so 24.7, product name, dataset ID, and what is the source for that. Okay, and I have a small model that I want to show you. So what I'm doing here is I'm using a make image server layer tool. This tool allow me to define cell size, extent, and output coordinate system. Okay, so like I said, when you are doing analysis, you want to filter one of the source, right? So I'm using here expression to filter just the Airbus WorldDEM4Ortho 24 meter, and I'm using cell size roughly of 25 meter. So it's 24.7, so I'm okay with some resampling happening. So I also defined the extent. It has to be less than 5,000 by 5,000. So you can define different output coordinate system. Here I'm choosing default, which is WebMaker in this case. So what is going to do is going to create a temporary layer, which then you can input into your other GP tools to perform further analysis, validate their model, and then run. Okay. So once you run that, it will take just few seconds to process. So it will create a temporary layer, and based on that, then it will generate contours for that area. So now we have a contours generated for my AUI using just Airbus dataset in this case. So I'm not, this data is not sitting on my local hard drive. So this is, I'm basically filtering data from this global elevation service and doing my analysis. So this is pretty powerful when you are when you want to do analysis using WebGIS. Okay, let me go back to my presentation here. So along with the elevation image services, Esri also offers elevation analysis tools for common tasks such as generating profile, viewshed, and summarize elevation. These works against elevation data hosted by Esri. These tools works now on 24 meter WorldDEM globally, along with the 90 and 30 meter option we earlier had, and 10 meter in data in few other regions. So these tasks require AGS subscription and burn 1 credit per 1,000 features. For example, if you input 1,000 points or polygons, you will be charged 1 credit. The maximum number of input lines is 100 for synchronous profile task, which is free. And let me now show you where you can find these analysis tools in a quick time. Now I'm here. I have opened ArcGIS Pro. Okay, so we have seen recently Hawaii Hawaii volcanic eruptions. So these are few fissure points basically along the lava path, and where the eruptions are seen on the surface, and I have added those points. And what I want to do is I want to see one of these eruptions or these areas, how far these are visible if I'm standing on the ground. So for that, you can do the viewshed analysis. Okay, so the three analysis are available. So if you look at the analysis tab, under the analysis tab, ready to use tools. So these are our online tools. So profile, summarize elevation, viewshed, these are elevation analysis tools. So these are available. So you can click on viewshed. So this will look like any other GP tool. Only difference is that it's working on data hosted by Esri. You have to just provide your input. So for example, you can select any point. So here I have one point selected, and then you can define different parameters. So under the DM resolution, so earlier it used to only 10, 30, and 90. Now we have added 24 meter, which is basically using the WorldDEM4Ortho dataset when you are running analysis. So you can choose that. So previously when we were using 30 and 90, it was basically SRTM, which was only covering North 60 to South 60. And now the tool works globally anywhere using the 24 meter. Okay, so to save some time, I've already ran that this tool, but I will show you the results. So you input the point here, and then you can run the tool. Okay, so once you run the tool, it will give you what are for this location is visible from which different areas on the ground. Okay, so you can do this analysis and take this output and use in your other workflows. Okay. So Out of these, so another tools are profile. You can generate profile along any line. Summarize elevation. Again, you can summarize elevations. It will, for a polygon line or points, it will give you min, max elevation along with slope and aspect for different areas. And you can explore these tools. So now I want to show you out of these three, two are available on ArcGIS Online. So if you are if you are a developer, you can use these as a REST from REST APIs also. Okay. Now I'm going to show you analysis, same analysis we shared I was talking in Pro in ArcGIS Online. So again, I have the same Hawaii area where I want to do analysis. So here I have opened the ArcGIS map viewer, which is ArcGIS Online. And there is an analysis tab. Once you signed in, you have to be signed in to use that. Okay, so under analysis tab, find locations, create view shed. So same tool that I was running there is available via ArcGIS Online also. So again, in this case, to save some time, I've already generated the view shed. So you select a point and run view shed. So this will give you. So if you click that, it will tell you what data set it used to run the analysis. So in this case, it's used a 24-meter Airbus WorldDEM. Okay, so now another tool which is available via ArcGIS Online is Profile. Okay, so here I have a few trails, and what I want to do is I want to build an app, web app, where basically I want my users to click on any of the trails and show them elevation profile, or even they can digitize their own path and it will return them elevation profile. So I have created this web map where I did a base map. I added my these trails which have certain fields, like what is the name of that, how difficult, or so how you can do how you can embed basically profile. So if you, there is a share button. If you say share map, under share map, you can share with whomever you want to share, and then you can click a create web app. Okay, so to create web app, you will see either you can search here profile, or in this case elevation profile is listed here. So you select the elevation profile and you say create web app. Okay, so once you say create web app, you can specify certain title, summary, etc., and then say done, and it will basically generate a web app which you can further configure a little bit. If you're a developer and want to do, you can even download the code to further. So I have already, again, to save some time, I already built an app which is pretty straightforward. So in this case, this is how the app will look like. If I click on any of the trails, so this is going to use the profile service, and this is going to return me profile for that area. Okay. So now I'm going back to my slides. So we have seen the analytics layers and we have seen analysis tools. So now we will talk about the visualizations, which are pure 2D and 3D. So ArcGIS 3D clients such as ArcGIS WebScene, ProScene, and ArcGIS Earth comes with default elevation surface to quickly generate 3D oblique views. This surface is a cache-tiled elevation service which encodes elevation value with low compression and is specifically created for generating 3D visualizations. In second, ArcGIS Online also provide a cached version of multi-directional hillshade, such as World Hillshade and terrain with label to use as a base map layer. So these World Hillshade is basically same as I was showing you that as a dynamic raster function, multi-directional hillshade. So we took that and make that as a base map layer, which is highly performant. So World Hillshade is also default to default backdrop to vector-based maps such as topographic, terrain with labels, street with label. We also have a world topo base, which is a newly released base map layer, where land use is fused with multi-direction hillshade, and it provides a unique look in comparison to the other base map we have. Now let's see quick demo again, where you can find these layers. Now I'm again in ArcGIS Online. Okay, so if you are on arcgis.com homepage, from there you can open the map. You can open the scene. Map is 2D view that I was showing you in all until now, where you can basically interact with all the map services, image services. And then we have scene. Scene is it's a 3D application. So it's a 3D globe which has elevation surface built in as a default. Okay. So I have here in this case I've opened a scene. So it's a web scene. And this is an example I want to show you before we release the WorldDEM4Ortho. So in this case, I am in I'm looking at the Singapore Central Business District. It's a reclaimed area. It's a totally flat area, but what we are seeing here is small hills. So this was previously what the services looked like with the SITM. So SITM has a DSM nature, as John was mentioning earlier. So with the DSM nature, which includes basically the buildings and all other natural and man-made features, so it includes the elevation values of the buildings. So because of the SITM coarse resolution coupled with DSM nature, so buildings, high-rise buildings basically look like a small hills, right? So So when you are using these 3D clients to overlay your buildings or your stuff on top of that, and if your surface is not aligned, you will see some problems. So we will quickly see in next example. So what the problem will be. So in this case, I have overlaid buildings, 3D buildings in Berlin to old surface, which was basically using the SRTM. And if I toggle back, so you can see there are small hills, though this is a pretty flat area again. So now with the newly released layer where we incorporated WorldDEM, so you can see how the surface looks pretty flat, which is supposed to be, because urban areas are flattened in WorldDEM. So this gives me a accurate surface to overlay my other buildings and use for visualization. So another example here in New Zealand, Auckland. And the first example would be again with SITM, where you can see it's pretty undulating, while in reality is flat. So now with WorldDEM, you can see the buildings are sitting on a flat surface very nicely. Okay, so with this, it really provides a good surface to start with. Okay, so next, so I mentioned that we also created the cached base maps. Okay, using these multi-direction hillshade. You can search again. I'm on the Living Atlas page where you can search world hillshade, and it will give you what you can open this in a different view, and there is a world topo base also, which is again based on which is using multi-direction hillshade. So from the base maps, you can specifically look for the vector tiles, and there are certain base maps which use relief as a background, and you can search that, such as a topographic map. If you open that, this will be using vector tiles and background or backdrop would be the world hillshade. So I have here quickly opened terrain with label. So terrain with label again is world hillshade plus some reference layers on top of that. So this is available out of the box as under vector tiles. So I'm here in the Salt Lake City. So you can use this to overlay your other visualizations, such as in this case I'm overlaying USGS earthquake faults. So you can use this as a backdrop for your applications or your, so you can see how nicely it's the overlay is being used in case of the world hillshade as a backdrop. So another example here, a quick example, you can overlay your other features, such as in this case, I'm overlaying land cover with the transparency over hillshade. So you can use these. So these are available out of the box as a base maps also. So where WorldDEM4Ortho is integrated. Okay. So with that, so there are a few resources which you can use, and that's all I have to share. Thank you.
All right, great. Thank you, Rajinder. So I'm going to go ahead and show my screen one last time. We did have a few good questions come through the questions panel. Since we're over time by quite a bit, I'm going to go ahead and forward those questions to John and Rajinder, and they can respond as needed. But I wanted to share this last slide with you. I want to thank you for attending the webinar, and I want to thank our presenters for presenting today. I'd like to apologize again for the audio issues that we experienced. And if you have any questions you think of after the webinar, please feel free to contact our presenters. If you have any general feedback, please feel free to contact myself. There will be a survey at the end of the webinar. It should only take you a minute or two to complete. If you could please complete that survey, that'll help us better plan and schedule our future webinars. Please follow us on Twitter, and if you have any questions about the Living Atlas, please ask those through our space in GeoNet, and keep a lookout for more webinars this year. Thank you again.